just in case there's somebody who's not here. So the topic for this lecture is about loops and variables. Loops being a special type of selection. We've done selection before. In the selection that we did the if then else kind of thing. So with a loop, we're going to do a while loop is the type of control structure that we use in this course. There is another kind of loop, a for loop, but a for loop is just a condensed way of doing a while loop. It's sort of like for super programmers. When you become a super programmer, you'll use, it's not that much of a super programmer thing, to be honest. I don't know, I'm sort of overstating it a little bit, but it's a little bit more abstract than a while, but you basically, you just do the same thing you do in a while, but with less words. So, I mean, it's cool. So you'll learn how to do that, not in this course, but in a later course. Yeah, so we're going to do a while loop, I think, in Python to sort of nail this down. But to be fair, what we really want to talk about in this lesson is, you guys ready? What we really want to talk about is looping, but also variables in the context of how do we know what the state of our computer program is. Now, by the state, we mean what is happening with all of our variables. We'll talk about that in today's lesson as well. So repetition, as it says here, repetition, we can take a bunch of code and do it over and over again. That is the key strength of computing from our point of view. That is that the computer is not smarter than people, but it's faster. Faster than people because it's got a clock speed of billions of cycles per second. You know, from the von Neumann architecture, you're doing three or four cycles to give you a line of code being processed. So even dividing by 3 or 4, you're still getting hundreds of millions of instructions per second being processed in your little computer on your phone. So that's a lot of speed. That's why we use computers, because of that kind of speed. Now, here we have, I hope you'll recognize that as a flow chart. This is actually a flawed flow chart. It's a flow chart that's trying to show an iteration. We use this word iteration, repetition, loop. They mean the same thing. That is that we're going to process the same thing over and over again. This one is flawed because it doesn't actually have the control structure. I hope you can see what's missing in this little corner down here. Can you see what's missing there? Down in this little corner, we would have something there. We'd actually have a diamond shape, which would represent that we have a control, let's see, there, where we're kind of asking a question. Is the number of iterations 10? You know, so we're repeating, but we have to have something to control the repeat. How do we control it? Or we're going to control it with a diamond in our flow chart. If the number of iterations became 10, then we stop. Otherwise, we can't stop. This still is not complete because how are we going to actually change the number of iterations? There's no way here to change the number of iterations. So when we're going to have a counted loop, we have to start with a count and we have to increase the count in the loop. Now, I should go back, I suppose, because I skipped over a couple of things. Yes. There's 2 different types of loops, and we'll talk about those both today. When we're talking about these different types of loops, we're talking about how do we control the loop? How do we decide when we're going to start, when we're going to stop the loop? And 2 different ways. We've got a counted loop and we've got a sentinel loop. The counted loop, we use that when we know before we start the loop, we know how many times we're going to do it. So we're going to do the loop 10 times. We're going to do the loop 20 times. Before we do it, we can say, okay, so we're going to count to 20. And then when we're done that, we finish doing the loop. Every time we go through the loop, we'll count 1 more. When we get to 20, we're finished. So that's a counted loop. We knew that before we started, we're going to do 20. The other type of loop is a sentinel loop. Before we start the loop, we don't know how many times. The user's going to tell us when we've done it enough times. And so we're going to ask the user some question. The user's going to answer, and depending on their answer, that's whether we're going to continue with the loop or not. You will see examples of that tonight. So the counted loop, we use that when we know how many times we're going to do it. Before we go into the loop, now this one won't work. It's trying to do a counted loop, but it won't work because there's no count. Yes, Omar.
I know how to use the diamond shape, but I don't know how to use it when it comes to a question. Because when a question it isn't clear, when should I do the diamond shape, or should I do on just a parallelogram or a square?
The diamond loop, there's two times that we would use it. So far, you've seen one where we'd have an if statement in a program. So if this condition is true, then we do this, otherwise we do that. So that's how it would be in a program. In this case, we're saying as long as the iterations are not equal to 10, then we're going to go back and do this thing again. Repeat until or while. So these kind of diamond shapes, the type of control structures that you will see will be either an if statement or a while statement. If it's not an if or a while, you probably wouldn't use a diamond. Or, well, there would also be a for statement, but you won't be using for statements in this subject. So this counted loop, I told you there were some things missing. Here we put in the things that were missing. If you're going to have a counted loop, you have to initialize the count. Initialize, have you heard that word before? Initialize means to have a starting value. When you start counting, you have to start counting somewhere, right? You usually start with 0 or 1, correct? That would be initializing the count. So we got a counter here. The counter is a variable called number of iterations, and we initialize it to 0. Make it 0 to start. That's our starting value. Initial is the starting value, right? And then before we check, we're going to increment. Increment means add a small amount. When you get a job at the end of every year, if your employer may give you a salary increment. Salary increment is increase your salary by a small amount relative to the rest of the time. And so here we increment the count, increase the count by a small amount. And then if that count now has become 10, then we stop. Because this is a counted loop, we knew how many times we're going to do it before we started. When we get to the number of times, we stop.
So when does no come to the equation?
When does who?
In the previous slide, there's a no. How do
Previous slide.
Yeah, this one. You continue after 0, right? After the first green rectangle, right? But there's another way you can go to.
We're going to continue as long as the number is not 10. When it becomes 10, we stop.
I mean, there's a no, right? How to get to the no?
Yeah, if the number is not 10, then we go to no. If the number is 10, then we go to yes.
Oh, okay. I see where the arrow goes.
Yeah.
The other way around.
All right, so let's do this counted loop. We've got another one that we're going to do, which is a counted loop for happy birthday. The person enters their name, their age, and that's how many times we're going to say happy birthday. So we would have a loop. Sorry, we ask the user for their name, for their age. So I'll just say input age. We get that from the user. So that's an input-output statement, right? From the age, we're going to have a count. So we're going to initialize our count. We've seen that before, right? Let's do it. Let's set our count to 1. That's initializing the count. Initialize our counter. Then we're gonna print happy birthday. That's an output. And then we're going to increment the count. Count takes, now I want you to look at that statement, count equals count plus 1. Mathematically, when you're in school, did you ever see anything like that? X is equal to X plus 1? Is it possible?
No.
In math, it's not. This is computing. This doesn't mean that the count is equal to count plus 1, because that's nonsense. That's not, it can't possibly be true unless 1 is 0. You know what I mean? So, you know, count is equal to count. What this means is there's a variable called count, and it had a value. We add 1 to it, and then we write that back to that variable. So the variable changes its value. Whatever its value was before, we add 1 to it, and that's its new value. That's what this means. This means a variable called count in the memory. We take its value, we add 1 to it, and we store that back in the memory on that variable. So if count started out to being 1, after this, it'll be 2. And go around again, it'll be another thing, right? So that is a process where we're incrementing the count. Increment means to add a small amount, the counter. And then what we do is we do our test. I hope you can see this. And what the test is the count less than the age? Or we're starting with a 1, less than or equal to the age. And if it is, then we keep going. That's yes. And if it's not, then we stop. That's a counted loop. Look like it's going to kind of look like the Python code. So I'm just going to go from the flowchart to the Python code. Input age. How we do that is we say age takes the value of, equal sign means takes the value of. We're going to convert it to an integer. We're getting an input from our user because it actually says that. And we're going to ask them what is their age. I'm asking them what their age is with the least number of letters because I don't really like typing that much. So we've done that. Then we're going to initialize our count. Count is equal to 1. So that means that we create a variable called count and we set its value to 1. Print happy birthday. I'm going to actually do this in a while loop. So I'm going to say while count is less than or equal to the age. Then we're going to print happy birthday. So that's printing the happy birthday once. And then we're going to increment the count. Right? That's it. It's not much, it doesn't take much programming to do that, does it? So let's run it and see if it's going to work. Happy birthday. Just HB. I was going to do HB, but HP is like the same, right? All right. Yeah. All right. So the age, let's say we'll have a small one, so it's easy to count. 6 said happy birthday 6 times. Okay. So it did this. Now, can we test to see that? Let's actually print their age, not just their birthday, but what is their age and the count. So happy birthday. What's their age? Oh yeah, it didn't matter that I have I wanted a comma there, sorry. And the count. So you can see what's happening with the count. Let's just do that. So let's run that. Age is 6. And do you see that the age doesn't change? That's because the age is outside the loop. First thing we did is get their age. That's 6, right? But we see that the count changed. First, we have a count of 1, count of 2, count of 3. So what's happening is these lines of code, these 2 lines of code keep getting repeated and repeated and repeated. How many times are they repeated? They're repeated 6 times. This is a loop that's controlled by a counter. Easy peasy? Japanesey. You could write a program like that probably, and you probably will sometime in the next couple of weeks. Okay. So I hope that was fun. Sentinel Loop. Yeah, we're going to have an example of the Sentinel Loop. So in the Sentinel Loop, at the start, before we do the loop, we don't know how many times we're going to do it. The loop is going to be controlled by something outside. So, for example, we might ask the user, you know, do you want to continue? Yes or no. If they continue, we continue in the loop. Otherwise, we don't. So just like that. So here's an example, which is you're running a shop. and you add a sale every time you sell something, you add it to a total. And you want to stop when you stop selling things. So how are you going to know when you stop selling things? Well, maybe you could have a value of 0. Oh, look, this is terrible. Because we're also missing our. This was done on purpose. I mean, it's a flawed flow chart that showed to you on purpose so that you can see what's wrong, and then we can see what's right. So what's wrong here is we're missing our diamond to control the loop. We got some stuff going on here in the loop. We're adding to the amount, but we have to see if we're going to add. So what we're going to do is we're going to use the current sale, the input that the user gives. And if that current sale amount is some Sentinel value, like 0, you know, if you had a value that nobody would ever have, we'll say, okay, well, if you give that value that nobody will ever have, 0, then we're going to stop our loop. And so we're going to add this thing here, which is going to be a test. Did you say that your current value is you had a sale of 0? Oh, that means you want to stop. So that's a Sentinel value. We're saying when you enter this strange amount that you would never enter otherwise, then you mean to stop. Otherwise, yeah, now this is where Sentinel values can get a bit messy. We're using Sentinel values of numbers because if we take that number and then add it to some total, it can mess things up, right? There are ways to get around that, but the best way might be to only ask for the Sentinel value just before you know, so you could take this process. Oh, sorry. Oh, goodness gracious. You can take this process here where you're doing the addition, do that after, don't do it, ask for the amount and then test. Yeah, and then only do this if the test is true.
Where you need to do multiple operations that depend on, in that would you use a Sentinel Loop or like a nested Sentinel?
So because you've got multiple choices, many multiple choices, it'd be a nested if type of thing, you know, and yeah, probably inside a big loop, you know, while true, and then you'd have some way of making it false, an if statement inside. That's how I would do it, I think, with a while true. But you know, it's a little bit more than complicated than what we're doing right here. But yes, yeah. So, all right. So the Sentinel loop, what we're doing is we test for some strange value. If that strange value shows up, we quit the loop. Otherwise, we keep going. And so, as it says here, you got to be careful with the values that you use. Typically, we might use a negative value, but make sure that if you're using this strange value, you don't add it to any totals or anything like that, because that'll mess up your programs. And as I said, there are ways to make sure you do that. You can only test the Sentinel loop right at the end of the loop, for example. So we got an example here, which is the one about cheating on my assignments. And so what we're going to do is we're going to do an output. I will not, whatever. And then we ask them if they want to continue. And if they say yes, then we continue. And if they say no, then we end. So that's the very simplest Sentinel loop, I guess. And again, so imagine that this is kind of like pseudocode. Because Python does look a lot like pseudocode, I guess. So this is, I will not put on my glasses so I can see.
So, what's the website for all that?
What is the website doing what? It's not a website. I've got idle running on my computer. It's called idle, IDLE. So if you want to use this at home, what you'll do is you'll go to python.org. Navigate to that. You don't have to here. If you want to do it on this computer, you just type idle and it will run this for you. If you want to get it at home, go to python.org and download the latest version of Python.
Do I go to the Windows or?
Yeah, go here and go idle. IDLE, Python. It should be on your computer. So I will not. Let's call this I will not. So what we're going to do is we just print, right? Print. Yeah. I will not. Whatever. And then we get some value from the user. So continue. No, not continue. What did I call it there? Repeat. Oh, repeat. That's terrible. Because it could be a reserved word. Let's just call it rep. So rep equals an input from the user. Repeat. Yes or no. The question. And so we're going to ask them, do they want to repeat? And if they do want to repeat, so this is where we're going to do the while statement. While rep equals y, then we're just going to continue. We're going to continue this forever, right? This is a Sentinel loop. All right, so let's see if that works. I will not. Will not. I will not. Maybe I will, but I'll say that I will not. Invalid syntax. Yes, when I can't believe I made that mistake, right? So this is a important thing in programming language like this in Python. There's a big difference between equality equals and assignment equals. We've been using assignment equals like here. This is very different. This is equality. When we want to do testing of equality, we have to actually use double equals, right? Double equals for testing equal. Yeah, this is my Sentinel loop. There's more than one way of doing it. There's a better way of doing it than this, but this is the first way that I'm showing you. Yeah.
Now, sir, why didn't you put a space between I as well?
Because it's a name of a file. So I'm going to type Y, and as long as I keep typing Y, it will keep saying I will not, right? And when I type something else like N, then it stops. Okay, so that's how the Sentinel loop is working here. As long as I type Y, go, 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 go. So that's what this was doing. Here I'm asking the user for input. If that input was a Y, then we just keep going. There's a loop. That's a Sentinel loop. Easy peasy? Yeah, all right. So we got our Sentinel loop. I'm not even supposed to be showing you this, right? You know, the other teachers are going to say, what are you doing? You know, they're not supposed to be seeing Python. Oh, that's a different one, right? So where was it? It was this one, right? Yeah, sorry. Just to me, I think that I think it's okay for you to see it, as you will be writing these programs. Yeah. What I mean is we're supposed to be focusing on the flowcharts, but I think you can understand the flowchart from the program as well, too. You see how they work together. Okay, but you don't have to do this now. But I see that Omar wants to do it. I think he's probably got idle running on his computer now, right? All right, that's why I'm not supposed to do it. All right, so that brings us to the end of that sort of concept there, where we were looking at the loops, the two different types of loops. Hopefully, the main thing that you're supposed to remember from that is counted loop. We use a counted loop when we know how many times we're going to do it. Sentinel loop. We use a Sentinel loop when we don't know how many times, but the user will tell us when they're going to stop. Counted loop, to make the counted loop work, we have to initialize a counter, then we have to increment it inside the loop. Sentinel loop, we just ask the user, do you want to stop? Do you want to stop? And we keep going as long as they don't say they want to stop. Easy peasy, got the two different types of loops. All right, so when I say the two different types of loops, don't get that confused with we're using a while loop. If you're using different programming languages, you might come up with a repeat until, while do while. Okay, so we're using while. The other one, as I mentioned, is a for. For is a lot neater, and it's shorter, and you'll lose that. But the concept is still the same. You know, are we going to do it a number of times, a counted number of times, or are we going to do it because some condition changes? Got the idea? Yeah. All right. So the ideas next, the next few slides are all about the state of the variables in the program. As the program progresses, the variables get initialized, they get their values changed. That's the states that we're talking about. Now, when I talk about the variables, I'm talking about a place in the memory has been set aside for each variable, and that can hold data. The data can change. So the program can put some data in there, and then it can change it and put some different data in there. We did that here, right? We created a variable here called count. We put some data in there, 1. Then, as the program progresses, that variable is still the same, but its value changes. It went from 1 to 2 to 3 to 4 to 5. Remember that? So, so the variable has a place in the memory. We give it a tag. We call it count. That's its name. And then we put a value in it, and we can change that value. And then we can look in our program. No, not that one. This one, right? Yeah, we can look in our program and we can see how that changed. I did that with a print statement. I could see that the variable called count started out with a value of 1, then it changed to 2, 3, 4. Okay, and we see that value changing as the program progressed. That's kind of a common thing that we'll do. All right, so there's 2 different things that we need to talk about there. Ooh, sorry. Now I think we got the memory idea down there. There's another similar thing that we store in memory. Store variables, but we store constants also. The only difference between a memory between a variable and a constant, with a constant, it doesn't change its value throughout the program, right? We give it a value at the start of the program. That's the value that it has until the end. No change. So that's quite useful in some programming things. So for example, it mentions, I think maybe in the next slide, that what if we're using mathematical calculations that involved pi? Pi is a mathematical constant. It never changes. And there's a lot of mathematical constants, right? There's constant for gravity, there's constant for the speed of light, etc. Right? If we're going to use those in a calculation, we wouldn't want to change them, right? We'd want that value to stay the same. And so we would set aside a place in memory and just put that value in there and just leave it. As long as the program's running, that's the value. Does that make sense? That's the difference between a constant and a variable. And so here mentions pi, because yeah, it's a constant. Well, now what you can see here. Yeah, and actually that the clue is in the name, isn't it? Variable varies. It's variable. And constant is constant. Yeah, doesn't change. Very good. So the clue is in the name. Now, so talking about names, when we assign a name to the constant or the variable with variables, now the program will work if you don't do this, but it's just better for you when you're reading the program or somebody else is reading the program that you follow this standard. And basically the standard is that with variables, we try and keep the variable name in lowercase, except if the name of the variable is 2 words together, the second word, or if it's 3 words together, the second, third, fourth word will be capitalized for the first letter. We call that lower camel case. Now, you've seen a camel, so you know a camel's got a hump in the middle, right? So you see the hump in the middle. I guess that's why we call it camel case. As opposed to the constant, where we put everything in caps. And the other thing in the constant is that if we're going to put two words together, we're going to use an underscore to join them. Okay, so constant. Now, as I said, you don't have to do that. You can have your constants all lowercase. You can have your variables all uppercase. The program will still work, but anybody reading your program will get confused, because what programmers are expecting is they're expecting to see a constant is going to be in uppercase and a variable is going to be in lowercase. Okay, so it's just a standard that people use to make their programs easier to read. Now, other thing, as I said, now the other thing is we try and make our variables meaningful names. We don't have to say student name here. We could have just said S. You know, and for Mac students, we could have just said M. And program will work perfectly. But the problem is you reading it, you go, well, what's M? So it's just better to say Mac students, because that's obvious. Oh, the maximum number of students. And student name, that's obvious, right? So we use obvious names for our variables. It's just good practice, because you want your program to be readable, right?
Now, sir, when you say student names, do we write the student's name?
This is the what's. Imagine you have a program and the program asks the user for their name. You store that name in a database somewhere. Then it would be appropriate, if you were asking students for their names, to store it in a variable called student name. If it was teachers that you were asking their names, it wouldn't be appropriate to put it there, because that would confuse people. So, you know, you just use a name which is appropriate for your program. Now, that's the thing, right? Programming, we're talking a lot about computer science ideas, computational thinking, etc. But programming is not just science. There's a little bit of art to it. You can put your personality and your creativity into it. So what I mean by that is, certainly in the names that you choose for your variables, they're your names. You get to choose it. You know what I mean? When you write the program, you choose the names. But when you do that, it should be obvious to somebody else reading it what it means. That's all, right? Personality, yes. Sorry.
There wasn't personality.
Yeah, yeah.
We could have seen the OS is all different than each other.
There wasn't personality, we wouldn't have Macs. Because if you look at Steve Jobs, he wasn't really a computer scientist guy. You know, he wanted to be an artist. You know what I mean? That's why we got the Mac computers. He was a smart guy. I mean, he could do computer science, but it was more, the thing that was driving him was his creativity. Yeah. So when we're storing variables, the variables are going to store a kind of data. The kind of data, for the different kinds, we call them types. And so here are some of the types of data. This is not all the types of data, but this is a good start on some of the types of data. So we have two different types of numbers. There's more than that, but you know, this is a good start. We got integer numbers and we got floating point numbers. Integer numbers, I hope that makes sense to you. They're like counting numbers, but they can include negative numbers as well. Floating point numbers, they include all your decimals. So that's a lot more numbers. And so floating point is going to take up a lot more space in memory. Characters, that's individual characters. So the individual characters on your keyboard, that's, I mean, you know, I don't know, we set aside maybe 255 individual characters that we can use. So there's not a lot. I mean, and so this is not the number 9. This is the character 9. And so we can use numbers for calculations, for mathematics, in which case they're going to be stored as integers or floating point. But if we're not going to use them for mathematics, we'll store them in a string, which is more than 1, or we'll store them as an individual character, which we usually call char, which is short for character. But these we can't do mathematics on, okay? The number 9 you don't do mathematics on.
You do, they will be printed as they are.
Yeah, it would be messy. So for example, we have some numbers that we don't want to do math on. You don't want to do math on people's phone numbers, right? You know, what are you going to do with it? Multiply it, divide it? Well, what use would it be, right? I mean, it's a phone number. It's an identity. You don't do math on people's student IDs. You don't do math on people's cutter ID, right? That's an identifier, right? So that would be stored as a string, not as an integer. Does that make sense? And we're not going to divide that number, multiply it. We're not going to do any of that stuff. We're only going to print it, just like a name. Your student number is just like a name. We don't do math on it.
So the difference between a character and a string is that the character contains more than one, and the character, the string contains more than one. The characters are
Exactly. Now, with our variables, we don't use numbers at the start of the variable. So a variable, no, this is not talking about variables, sorry.
Why are there like commas?
Why are there what?
The characters.
They have the quotes on it.
Yeah.
So that's to show that it's a number will never have those. All right. So when we use a character or a string, if we're entering it in as an input, then we have to put the quotes for characters and strings. For numbers, we don't put quotes. Does that make sense?
Yeah, and that's why you put Y in.
Yeah. Yeah, that's why I put the Y with the quote on it. Very good. All right. That is represented right here, Omar. You see that there? Oh, it's right here. We use the quotes around it when we're displaying a string. When we're displaying an individual character, we might just use we can use double quotes or single quotes. It doesn't matter to the computer, right? It doesn't care as long as you've got quotes. All right, so what do these things mean? So I told you that this does not mean that count is equal to count plus one. What it means is count takes the value of whatever count was plus one. So that's the same here. What this means is whatever is in the value of A will be added to whatever is in the value of B, and then that will be stored in the variable called C. That's what that means. And then we can display it. And we display it with a prompt. Now, program state, we measure that by looking at the variables. What is the value of the variables? We can do that a number of ways. You can get a data dump on your program. That's a nice way of doing it. There's tools that allow you to do that. Or for us, just simply, we can just do a print. Print, what is the value of that thing? So we got another program to do here, it looks like. Happy birthday to you, age, number of times. Didn't we just do that? Haven't I got the happy birthday program? Let's look. Happy birthday to you a number of times. Yeah, there it is. Now, what if we wanted to know what is the state of every variable as we, no, that's the wrong one. Happy birthday to you. Where are you? Yeah, there we go. So what if we wanted to know, we could put a line number on each of these things, right? Now I can put so this is line, let's say this is line 1. This is line 2. Line 3. So whenever I put a hash in Python, that means whatever follows the hash on that line will be treated as a comment and will not be processed by the computer. And that's what we want, right? So the reason why I'm doing this is because I want to see what happens as I go line by line. So there's my line 5. So now if I print, in the print, I'm going to print the line number, right? So let's print those. Print. So what's happening in line 1? So I'll just say line 1. And whatever is there. Well, the only thing that's there is age. So what is the age? How did it go after line 1? So there's my age. There's only one variable that's alive at this point, right? That's age. Now, when I get down to here, I got 2 variables. So I'm going to take this, I'm going to copy it. Now I've got 2 variables, right? So I've got age. This is now line 2. I've got age and I've got count. What is the value of count at line 2? What's the value of age and count? So here we got count. So that's fine. I can print those. Now I'm going to see what's happening at these other lines. So what I'm doing is I'm trying to see what is the value of everything as the program progresses. Now I'm at line 4. I got my age, I got my count. Is there anything else? No, that's it. And line 5. So I can see what happens to the program as the program progresses. Let's run it and see. So let's say the age, I want a clear screen. We'll just do 4. The person is 4. So at the start of the program, we can see here what's happening with the program as we go, I hope. Let's move that over there. There we go. So at the start of the program, the first thing it does is the user asks. Oh, shit. Oh, that's so annoying. All right, so the user is being asked what is their age here. That comes here, right? Then we're printing that this happened on line 1 and we show the age. So we see that happening, right? They typed age 4 and we got that. Okay, and we see that that age never changes. So we're going down there, we're doing line 1, line 2. Now notice the progression of this. We got line 1, line 2, line 4, line 5, line 4, line 5, line 4, line 5, line 4, line 5. That's a loop, right? How many times did we do line 1 and line 2? We did them once because they happened before the loop. Then the loop started and we just kept on repeating line 4, line 5, line 4, line 5. That tells us we're in the loop, right? Then eventually we got out of the loop. What I should do is I should, after the loop, I should print a statement which says, oh, not there. Yes, here. So now I'm outside the loop. I'm gonna print finished. But then I'm going to print, and so this is going to be line what? What line is this? This will be line 6. So our program's got 6 lines, and then we'll print out and see what happens at line 6. So at line 6, the only variables are still age and count. Let's run that. Run. So let's just do this let's do it for 3. We don't need to go too many times. Age 3. And so we can see, so you see that line 1, line 2 happened once. Then line 4, line 5, line 4, line 5, line 4, line 5. Those are repeated 3 times as we predict in the program, right? And then line 6 happens once, right? The count, when the count became 4, now the count became 4, but there's only 3 times, right? Because how did this loop work? As long as the count was less than or equal to the age, which in this case, the age is 3, then we'd stay in the loop. But eventually the count did become 4, but that's when we quit it out of the loop. And so we only see that there. Anyways, what was I trying to show you there? I'm trying to show you, we saw the this is actually this program. We saw the flow chart, and now we're seeing the states of the variables. That's what I want you to concentrate on. As we go through the program, the variables change. Now, some of them don't change, right? Age never changed because in the program, we asked them their age and we didn't change it. But the count changed, right? The count changed, and well, that's the only thing that changed. Count changed and our output changed. Anyhow, I'm just repeating myself at this point, and so I'm going to stop. Yeah, because you want to do it, don't you?
Yes, but there's something wrong with my item.
That's why I wasn't supposed to show you this.
No, it doesn't matter. I forgive you.
It's okay. I don't mind. There it is. There's a whole program. So actually, I should be happy that you want to get ahead and start writing programs. That's great.
But there's something wrong here, especially in the item.
All right, I'll come and have a look at it in a minute. All right, so any other questions on this? It's okay? All right, I think I'm done talking to you then. Is that all right? So there is a tutorial and there is a lab and there is an assignment and we'll start on those in the next lesson. I'm going to stop and I'm going to stop this now because I'm going to go and have fun with Omar fixing his program. We call that debugging.
Don't say it like that.
Debugging.